Hello, hello. I hope you guys are doing well. Obviously, by the time you're watching this, I'll be at Year 9 camp enjoying myself, and you guys will be stuck at school. So, oops. So we had a look at 1.1, which was simple interest, and that was good. That was pretty good. You guys responded really well to it, especially when we started doing some questions. Now, moving on to something called compounding interest, and it's more of a realistic approach towards interest but also a much more difficult approach. I was reluctant on setting this to you guys because without me there or a math teacher there, it can be pretty hard to kind of do it. But I have faith in you guys. You guys are really strong. And genuinely, I'm very impressed by you guys and your mathematical abilities. So I have no doubt that you guys will be able to get it. If you don't, ask someone around you, and I'm sure they'll be able to help you. So let me maybe move my camera to the other side actually. So that's wrong. Didn't do that. There. All right. So title is 1.2 compounding interest. So far I've looked at simple interest. Just a recap. So maybe I'll just do a recap. Recap. So for a recap, simple interest. So simple interest uses the formula I equals PRT. And you guys have got this drilled into you now. I've made you do a lot of questions there. So the interest or the amount of interest earned is equal to the principal you put in, multiplied by the rate of interest, and that gets multiplied by the amount of time it's in the bank in years. So initially, or not initially, so essentially you're only getting interest on your principal. Let's look at a situation here. So let's look at a scenario. Let's say that I put in $5,000 into a bank at an interest rate of 6% for 3 years. So let's say I put in P is equal to $5,000. So my principal is $5,000. My interest rate is 6% for a time of 3 years, we'll say. If I wanted to calculate how much interest I earned on that, I'll simply put it into the formula I equals PIT. So I is equal to P, which is my principal, which is 5,000. That gets times by my rate. Remember, when we're talking about rate, I don't want it in percentages, I want it in decimal. So I take my percentage and divide it by 100. So I do 6 divided by 100, which is 0.06. And then that gets times by the years. So I get 5,000 times 0.06 times 3, and if I pop that in my calculator, 5,000 times 0.06 times 3, I'll get an answer of $900. So over 3 years, I've made $900 just in interest. So if I wanted to work out the amount of money I have in the bank, remember the total amount, which is A, is equal to principal plus the interest earned. So 5,000 plus 900 is 5,900. So at the end of these 3 years, essentially I have $5,900. I'll put my principal in it, and the bank has given me 6% on that principal over the course of 3 years. Let's look at a different situation. All right, I'm just going to draw a line like this to show that we're looking at a different situation. Let's say I still put in $5,000, so my principal is still $5,000. My rate is still 6%. But instead of keeping it in for 3 years, what if I keep it in for 1 year? So my T is equal to 1. Now, if I want to work out how much interest I've earned, I use the same formula. I is equal to PRT. We get 5,000 times 0.06 times by 1. Pop that in the calculator, you get $300. So after this 1 year, I've earned $300 in interest. So my total amount that I have is $5,300. I'll make that more spaced out. So in this situation, I've only kept it in for 1 year, and you can see I've earned $300. Let's say at the end of that year, I changed banks. Essentially, I withdraw all that $5,300 from my bank account, and I go put it into a different bank that has the same interest rates, and also for a year again. So let's just say year two, right? So before was my first year, now I'm year two. My principal is now $5,300, right? Because I've taken that money out of that bank account and now putting in a different bank account. So my principal is now $5,300. My interest rate is still the same, so it's still 6%, and my time is still 1 year. I want to work out how much interest I've earned, so I pop it in the formula. I equals PIT. I is equal to 5,300 times 0.06 times 1. Pop that in the calculator. I got 318. Hopefully you guys did too. So I've earned $318 on my interest now. So because I took the money out of that bank account before and I put it into a different bank account with the same interest rate for the same year, because my principal is more, I've actually earned more interest. So now I got $318. The total amount I have in my bank is 5,300 plus 318, so $5,618. Now for the third year, I'm going to do the same thing. So now for year three, I'm going to do the exact same thing. My principal, so I've taken that money out of the bank account and I'm going to put it back into my first bank, which still offers me 6%, but my principal's now changed. So now my principal is 5,618. My rate's still the same. And my time is still 1 year. I pop it into the formula, I equals PRT. I put in the numbers 5618 times 0.06 times 1. So I've earned $333.08. I'm going to squeeze this in. So the amount that I've made, or the amount I've got now, is $37.30 plus 5618. So I've done my principal plus my interest, and I get 5955.08. So in my simple interest, where I kept it in the same bank and it just made interest on the principal, if I kept it in for 3 years, you'll see that I would have $5,900. But in this situation, I've kept it in for 1 year. I've withdrawn the entire amount. I've put it in a different bank for year two. After the interest is earned, I've taken that interest out. I've taken all that money out and put it into a different bank. And you see that after 3 years, I have $5,955.08. So by taking out my money, taking out that interest I've earned, and making up principal higher, you can see that over 3 years, I've earned an extra $55.08. This is kind of the idea behind compounding interest. So this is more of a realistic thing when it comes to bank loans, home loans, car loans, also when you put money in the bank account. Our interest gets compounded. So on our, not on our principal, but it gets on our principal plus the interest. So, compounding interest is essentially where instead of it just going on the principal, we earn interest on the interest we've already earned. And that's essentially what's going on in this situation here. So we've earned interest, we've earned $300 interest, and now we're getting interest on this principal plus the interest, which gives us some more. And then we're earning interest on the principal, which earned interest twice. And that's the idea of compounding. So it compounds, so it goes on top of that. So that's really all I want to, the theory I want to go in on camera. When we come back in class next week, I'll go over compounding and in real terms more. But that's all the kind of theory I want you to kind of understand. Now I'm going to teach you the formula. So when we see compound interest, there is a formula that we follow. And it goes like this. Let me just bring my laptop over. So, compound interest formula. I'll move my camera again. So the compound interest formula is as follows. It goes A is equal to P bracket 1 plus R bracket to the power of N. So interest formula is A is equal to P 1 plus R to the power of N. Let's define everything. So we say where A is equal to the amount at the end of the process we'll say at the end of the process period, same thing. So A is equal to the amount that we either owe or the amount that we have at the end of the process. P is still our principal. So still that initially put in. Our R has not changed. Our R is the rate of interest. And we still want that in decimals. But now we have this N. And this N is a number of compounding periods. And that's just saying how many times is the interest being made on the interest, on the interest, on the interest, on the interest. And again, like I said, this won't make much sense to you guys now. When I come back to class, I'll explain it all a lot better and use examples where it can actually relate to you guys. But if you're here, I just want you to know the formula and kind of how to apply it. So we're going to do this question. So I want you to basically pause the video and go ahead and copy that question. Do it now. All right, welcome back. So in this question, it says, Clive borrowed $12,000 to buy a lathe for his factory. He agreed to pay interest at a rate of 15% per annum and to repay the loan in the full 3 years. Calculate the amount to be repaid if the interest is compounded annually, half yearly, and quarterly. So we see the word compounded, so we know we're talking about compound interest, so no longer talking about simple interest, talking about compounding interest, which means we're using that formula we talked about before. Let's go ahead and highlight what we know. So we know Clive has borrowed $12,000, so our principal is $12,000. He agreed to pay at an interest rate of 15% per annum. So we have our interest rate, and he's paying it over in 3 years. So we have our time. Now question A says, calculate the amount to be repaid if it's compounded annually. And this is where that new part of the formula comes into play. So I'm going to rewrite the formula like we always do. It should be a habit to write the formula. And the formula says A is equal to P bracket 1 plus R to the power of N. And what I like to do is I like to write the values below it. So we're trying to work out the amount. We're trying to work out A. Do we know the principal? Yes, the principal is $12,000. So the principal is 12,000. The next part of the formula is the R. Do we know the rate? Yes, it's 15% per annum. So it's 15, but remember we want it as a decimal, so they're 15 divided by 100, which equals to 0.15. Now here's a new part. So compounded means how many times the interest being made on itself. Because it's being done annually, that means it's being done 3 times. So it's compounded once per year for 3 years. So if it's once per year, that's 1 times a total of 3 years. So 1 times 3, which equals to 3. So that tells me it's compounded 3 times altogether. Now that I know everything, I can pop it into the formula. I'm going to do it on the right hand side to save space. So A is equal to P bracket 1 plus, oh sorry, now instead of the letters I'll do the numbers. A is equal to 12,000 bracket 1 plus 0.15 close bracket to the power of 3. From here, just pop that in your calculator. You have no reason to do anything by hand. You should all either have the CAS calculator, the white one, or your green calculator. Both of them are capable of doing this. So you would just do 12,000 times bracket 1 plus 0.15 to the power of 3, and you'll get an answer of $18,250.50. So what this means is that if Clive takes this loan and his loan compounds annually for a course of 3 years, he's paying $18,250.50. It's compounded yearly, so once per year, and he's got it for 3 years, so it's compounded 3 times. So that's how he got that formula. Let's go ahead and do question B. Question B says it's now compounded half yearly. So, same thing, I'm going to write the formula out. A is equal to P 1 plus R to the power of N. My principal is still the same, which is 12,000. My rate is still the same, which is 0.15. But now my periods have changed, or the amount of time that's compounding has changed. So now instead of compounding annually, which means yearly, it's half yearly. So per year, it compounds twice, because there's 2 halves in a year. So we do 2 times how many years the loan is. It's for 3 years, so we do 2 times 3, which equals to 6. So it compounds a total of 6 times. From here, exactly the same, I'm going to copy the numbers into my formula. So A is equal to, the principal is 12,000, bracket, 1 plus 0.15, close bracket. Now the N value changes from 3 to 6. And now if you pop that in your calculator, you get an answer of $18,519.62. So if it compounds half yearly, he ends up paying more than if it compounds yearly. So now he pays $18,519 on that $12,000 loan. Let's go ahead and do question C. Question C says it's now compounding quarterly. So again, we're going to write the formula out. A is equal to P 1 plus R to the power of N. My principal has not changed. My principal is still $12,000. My rate is still 15%, so 0.15 as a decimal. Now my compounds, or the amount of times it compounds, has changed. My periods, the amount of times it compounds, they mean the same thing. So now it's done quarterly. So how many quarters are in a year? Well, quarter means 4. So there's 4 per year. Times, the loan goes for 3 years, so it gets times by 3, which equals to 12. So now it compounds 12 times. So every 3 months, it basically gets interest on top of the interest it's earned. So in the formula, we'll get A is equal to 12,000, 1 plus 0.15, and now my compounding periods has changed to the power of 12. Again, you pop that in your calculator, you get $18,665.45. What I want you to take away from this is the more it compounds, the more interest you either pay or the more interest you earn. So in a loan, you want it to compound less, but if you're putting money into the bank as an investment, you want it to compound more frequently because then you're making more money because you're earning interest on top of that interest you earned. So, like I said, I understand if this is a lot to take in. You guys can pause, take notes wherever you need to. Just try your best, that's all I can ever ask. It's going to be in the worksheet again. If there's anything you stuck on, feel free to email myself or Mr. McHale. he'll be on site, so he won't be on camp, so he might be able to help you better than I can. But other than that, these are the questions I want you to do. So in the worksheet, I want you to do these questions. Questions. What is it? 1, 2, 3, 5, 8. Yep. I want you to do question 1, 2, 3, 5, and 8. And if you finish it, good job. I'll be checking it. We're checking it and we're going through it when I come back next week. So if you don't get it, please don't stress. Try to watch some videos. Try to ask people who understand it. And yeah, I'll see you guys.